Hello everyone. Yes, this is third movie of chapter 2 that we continue from the second movie. Okay. Uh, the ending slide of second movie. This is the ending slide of second movie. So yes, all of you have done this already. And yes, from this slide, this is for this movie. Okay, now this movie starts from constructing frequency distribution tables or constructing frequency distributions. Previous in the previous movie, we construct or we make frequency table when we have a data set. When we have data set and our data set is qualitative data, so we use a qualitative data set in order to construct to make frequency table. But in this point, if you have data set, your data set is quantitative data. If you have data set and your data set is quantitative data, when you want to construct frequency table, you need to construct frequency distributions or frequency distribution tables. So again, in order to make frequency table, you can use both data, qualitative or quantitative. If you have data set in terms of qualitative data set, you can construct frequency table. But if you have data set in terms of quantitative data set, in this point we can construct frequency by more than previous one that we call frequency distributions or frequency distribution table. So this point, constructing frequency distribution table by using quantitative data set. Okay. The procedure we present for organizing and summarizing a data of quantitative data of a set of quantitative data set if the frequency distribution or the frequency distribution table. Okay, so this slide will tell you how to construct frequency distribution tables. So when you want to construct, you need to have data set, and your data set must be quantitative. Okay, so before constructing a frequency distribution or frequency distribution table, you need to understand what is frequency distribution table. Frequency distribution is the methods or is the statistical technique that we use in order to group, in order to classify. Okay, in order to classify the quantitative data into mutually exclusive categories or groups or classes. Okay, classes. And maybe I think you still remember what does it mean mutually exclusive. Okay, so you not remember, okay, go back to the previous video and then you can track to the point that explaining mutually exclusive. Okay, so previous video that I mentioned is about chapter 1. At the end of the chapter 1, you still remember, there are 4 levels of measurement, data measurement: nominal, ordinal, interval, and ratio. This point is in nominal explanation. Okay, you can go there. So frequency distribution is a statistical technique that we use in order to group in order to classify, in order to categorize the quantitative data into mutually exclusive categories, groups, or classes, showing the number of observations or data items in each category, each group, or each class. Okay, so frequency distribution table is the way that we grouping, or is the technique that we group, that we classify, that we categorize our quantitative data set into mutually exclusive categories, classes, or groups that showing number of observations or number of data items in each class, each group, or each category. So question: how to develop, or how to make, or how to construct a frequency distribution table? Answer: in order to develop, in order to make, in order to construct a frequency distribution table, we need to follow 5 steps. 5 steps. As step 1, you need to decide. Okay, you need to decide how many categories, how many classes, or how many groups that we need to make for our table. That we need to make for our table. It means we need to find K. So K is the number of classes. How many classes? How many categories? K is number of classes, or number of categories, or number of groups in our table. Okay, you need to find K. How to find K? In order to find K, you need to follow this formula. This is not equation, this is inequalities. Okay, you can see inequality, this is bigger. So you need to follow this formula. The formula states that 2 exponent K bigger than, greater than n. What is n? Okay, K I mentioned already, but now what is n? N is the number of data observations. N is the total number of data observation or data items in our data set. Okay, in our data set. For example, I have your class. Suppose that your class have 50 students. Your class have 50 students. So I want to, yes, I want to allocate, I want to make frequency distribution for your class based on maybe age, okay, or based on money that each student have in their pocket, maybe based on age. So if I have 50 students in the class is data set. The class is data set. Each student is data observation or data item. That's why your class 50 and is equal to 50. If your class consists of 50 students, so if I want to classify your class data set into frequency distribution table, how many categories, how many groups that I can make or I need to make. That's why I need to follow this one. So I need to follow this one. I need to take 2 exponent K greater than 50. That's why I need to test. Okay, I need to check, test or check. So what K that 2 exponent to that number that greater than 50. Okay, maybe you can get calculator to take, or maybe if you are smart enough, if your brain work well, you can use by your brain. No, you don't need to make to use a calculator, your brain. So 2 power or exponent what number that greater than greater than 50. Okay, let's check. 2 exponent 2, 4, 4 smaller than 50. 2 exponent 3, 3, 9, right? 8, sorry, 8, not 9. 2 exponent 8, 3 is 8. 8 cannot be greater than 50. So 2 exponent 4, 16. 2 exponent 5. So how much? 2 exponent 5? 32. 2 exponent 6. 2 exponent 6, how much? What is it? 64. 64 greater than 50. Okay, that's why I can say that K is 6. So if your class consists of 50 students, I can allocate every student in the class into 6 groups. So when I want to make table, you must have 6 groups in this table. But now, in short, step 1, we need to decide how many categories or how many classes in our table. In order to decide how many classes or how many categories that we label by K, we need to follow this formula. Step 2, determine, or you can set the class interval or class width that we call I. I stand for interval. I stand for interval. I. Class interval or class width. What does it mean, class interval or class width? Is the gap between beginning of the class and ending of the class. Okay, so interval is a gap between is the distance between beginning point and ending point. So class interval must be the same number, the same distance, the same gap between one class to the other class. So every class in our table must have the same number or the same distance or the same gap from one class to the other class. In order to set I, you need to follow this formula. I greater than H, capital H minus capital N divided by K. K here you get from the first step. Okay, K here you got from the first step. How about H, capital H? And how is about capital L? Yes, I is class interval or class width. K is number of classes in our table. But H, capital H, is the highest observed value or the highest value of data item or observation in our data set. In our data set, the highest is only one item or only one value. That the highest cannot be 2, cannot be 3, only 1. They call highest. How about capital L? Capital is the lowest observed value, the lowest value of data item or observation in our data set. That's why we're talking about lowest value is only 1 in our data set. For example, I'm talking about our example. Your class have 50 students. If I study about 50 students, but I'm talking about age. So among 50 students, only one age is the oldest. Only one age is oldest, and only one age is the youngest. Okay, we're talking about age. Only one age is oldest, only one age or youngest. For example, I can say that. Okay, among 50, some student 19, 19, some student 20, some student 21, some student 22, some students 23. So 19, 20, 21, 22, 23. This is the age of 50 students. So which one is the oldest? 23. 23 is the oldest. How about youngest? Youngest is 19. That's why age is 23. L is 19. Okay. So if you can find, just based on the data set, you can find capital H and you can find capital L. and then if you know H, if you know L, you can minus H minus L, you know result. And if you know result, you can divide it by K, because K you found from step 1. This result coming, remember, I is not this result. I must greater than this result. Okay, this result, the calculation here, I is not equal. Yes, if you go to textbook, the textbook have equal, greater than or equal, but I recommend you not setting equal, must be absolutely bigger, not equal. Okay, so I is the number that you can give, that you can determine, that you can set. Those numbers must that numbers must greater than this result from calculation. Maybe now you can find it's hard to understand. Okay, just looking this step 1, step 2, try to understand. Even though you not a clear understanding, when we go to exam hall, you can be clear understanding. Step 3, determine the individual class limits. What does it mean, class limits? Class boundary, class border. In order to put individual observed value data item observation from data set into the right mutually exclusive classes or groups or categories. Okay, what does it mean, class limits? Class limit, like you need to yes, before you get to the class, you need to start and ending. Okay, your class, start and ending. That's why start limit is the point that the something that the number, the difference between the starting number and ending number in the class. Because in one class you need to start one class and ending one class. Before you, if you don't ending one class, if you don't end one class, if you don't if you don't limit one class, you cannot continue to the class 2. Okay, so that's why class 1 must be start and finish, and then when you finish class 1, you need to start class 2 and finish class 2. When you finish class 2, you need to start class 3. Okay, that's why what is start class limit? Class limit is the limitation between beginning class and ending class. And then when you end beginning and you ending of the first class, you start beginning of the new second class and ending of second class. And then when you ending the second class, you start the beginning of the third class and ending of third class. That's why class limit is the gap between beginning point to ending point of each class. Okay, it means that we need to find H. Step 2, we have capital H, we have capital L. Capital H, remember that this is the highest observation value in our data set. Our data set means raw data. Capital L is the lowest. That's why H only 1, L only 1. But step 3, I label H but not capital. It's small h and small l. Why I put small h, small l? Because this is talking about highest class limit of each class. This is low class limit of each class. So every class have low limit or starting, and high limit is ending. Okay, low limit is starting point or starting number, and higher limit is ending number. Okay, so it could be, if you're talking about class 1, L1 H1, class 2 L2 H2, class 3 L3 H3. That's why I put a small h and small l, because we have many small h, we have many small l. It depends on what? It depends on k. If you have 5 classes, in your table must have file H, and also you must have file L as well. So that's why depends on how many classes, depend on K. Step 4, tally or mark. What does it mean, tally? Just put a mark, make a mark. I mean, tally, you mean you got a concept from statistics. Maybe you took class 7, class 8 secondary school. Yes, tally or mark every individual observed value from dataset into each class. Tally, that means transfer. I can transfer each item from our dataset into the right class. Okay, went into the right class. Okay. Step 5, count the numbers of observed value in each class. Count, that means how many. The number observation in each class we call class frequency. Okay. Step 5 is to find class frequency. So maybe back again. Step 1, you need to determine, you need to know how many groups in your table. Step 2, you need to find class interval, this class gap. Okay, interval. Remember that from ending our chapter 1, if data set from one data item to data item is row gap, this is no interval. That's why interval must have a gap or distance. But in this case, class 1 interval, class 2 interval, class 3 interval must have the same distance, the same gap or the same number. So in order to define, in order to determine, or in order to set a class interval, you need to calculate this calculation, this formula. When you calculate this formula, you got the result. I is not equal to, I must be greater than this. You need to give the value of I that greater than this result. Okay, so what number that you need to give, I will tell you, or I will explain you in example. Step 3, you need to find class limits, because we're talking about class interval. Class interval must be the same number from one class to another class. That's why every class must have the same interval. In order to get interval, must have beginning point, ending point. Okay, the gap between beginning point and ending point is called interval. But in our step 3 right now, I'm not talking about beginning point, I'm not talking about ending point, but I'm talking about low limits. The gap between low limits to high limits must be the same from class to class, from one class to the next class. Okay, that's why step 3 you need to find class limit. You need to find L1 H1, L2 H2. Step 4, when you know class, when you know class limit, you know class interval, you can go back to data set, and then you can transfer every item in our data set into each class, into the right class. What this number we need to take into what class? Class 1, class 2, or class 3. It depends on number. Okay. And step 5, when you are finished tally, when you only finish marks, that means you can count a number observed in each class, observation value or observed value in each class. So those number that we call class frequency. Because why we call class frequency? Because every class in our table must have this value. Okay, must have the value. Okay, this is a 5 step already done. This is the way that I explain. Maybe you still not clear. You're still not clear for this one. Okay, you can go to example. When we look at example, and then you go to back to this step 1, step 2, step 3, step 4, step 5, and then you can cross check. Then you can you can get the point. Okay, now going to example. Suppose that example, here is the data set of the selling prices of cars. I say car, not vehicle. It's a car. This is the price. This is the data set, the selling price of the car that company sold last month. The company sold last month by Rob Widener. Okay, by no. So by Rob. Rob, the company selling the car. Last month, Rob could sell the car with the price. Okay, with the price. So every car sold with different price. From one car to next car, maybe they not selling the same price, sell different price. That's why this data set is about selling price of the car sold last month. So how many car was sold last month? How many cars were sold last month? Based on this one, there were 80 cars sold last month. That's why when you count this number, this is 80 numbers. So what this number represent? This number represent selling price. For example, the first car, this is the first car. Last month, this is the first car sold. The first car sold at price $31,373. Okay. Second car, third, something and on, last up to the last car. This is the last car. Okay. Or this is the last car. I don't know which you can. This is last car or this is last car. If you count from the up to the bottom, this is last car. But if you count from the left to the right, this is last car. So it doesn't matter. That's why I don't say last car, this one or that one, but I'm just saying this is the first car. Okay, the first car sold last month. The price was 31,373. Second car 39,552. Or this is a second car. It depends on which direction that you count. You can count the second car, or you can count the second car. But this is the first car. Okay, this is data set about selling price. Okay, selling price of the car. So now what you get from this? Because this is a number. This is quantitative data set with totally 80 selling prices from 80 cars sold last month, because each car sold with its own price. Okay, each car sold with its own price. So there are 80 cars. So what we get here, you can get n. Okay, you can get n. This data set n is 80. If you can get n, so you can define how many classes that these prices group into, how many categories or how many selling price groups that these selling price count into or take into. So in order to find how many classes or how many groups, you need to remember 2 exponent k greater than n. 2 exponent k greater than n. N is 80. It means 2 exponent k greater than 80. So what is k? You can check or you can test by calculating by you use your brain or by you use your calculator. That if you are smart enough, maybe you don't need to use calculator. You think a little bit, you can find. And then when you can find k, step 2, you need to find I, class interval. In order to find I, remember from step 2, I greater than capital H minus capital N divided by k. So suppose that you found k from the step 1. Now you need to find capital H. There's only one of selling price. There's only one of selling prices here, that the most expensive car. Which one? And there's only one of 80 selling price here is the cheapest car sold last month. That's why you need to find the highest value in this data set, and you need to find the lowest value in the data set. The best way in order to find without taking many minutes or taking a bit longer time, you need to see heading number. Okay, you need to check every number, but don't look all, just see heading number. So if you want to find highest, you need to find heading number. Okay, this is this column heading number. The biggest heading number is 4. This one 3. Okay, if 3 we don't look at because smaller than 4. 5. That's why 4 here, 4 here. No, that's why we take 5 here. Look at the other one. 5 here. That's why we have 2 columns with the heading number 5. How about this one? No, number 5. Don't look at this one. No, number 5. Don't look at. That's why you don't need to look at this column and which one, and this column. 1, 2, 3 column. No, you don't need to look at, and the last 2 columns you don't need to look at. That's why you look at only 2 numbers here, 50 and 50. Okay, 50 and 50 are the same. That's why you need to look at the next level or next digit. This is number 7. This is number 5. That's why this is the biggest one. Okay. Do it the same way. You need to look at the cheapest car sold last month. The cheapest, it should be heading number again, but the lowest number. Okay, this is number 2 lowest. This is number 1 lowest. Okay, I take this one. That's why not this one. No number 1, not taking this one. No number 1, not taking. Yes, number 1 here. Okay, taking. Number 1 here, taking. No number 1. That's why I don't look at column 1. I don't look at column 3. I don't look at column 4. I don't look at the last column. That's why I look at only column 2, column 5 and 6, and then 19. Same 19. Look at next digit, next number. 7 3 9. 3 lower. Okay, 3 lower. That's why based on this slide I can find 2 steps. Step 1 I can find K. Step 2 I can give I. Okay, step 1, N is 80. Why I put capital N? Because this is population data set, not sample data set. 80 cars sold last month, no more, no less. 80 cars sold last month. This is population. Okay, I can test if let if k equal to 6 exponent 2 exponent 6, 64 is smaller than 80, so no. So k equal to 6 is not. 7, 2 exponent 7 equal to 128. 128 is greater than 80. That's why I will take k equal to 7. Why not 8? 8, 2 exponent 8 is bigger than 80, but too much bigger. I don't take too much bigger. I just take a little bit bigger than. Okay, a little bit bigger than is 128. Not 200. Should be 256. Okay, if k equal to 7, equal to 8, 2 exponent 8 must be 256. 256 greater than 80. Yes, that's correct. Based on our formula, but this number is too much greater. I don't need too much greater. I just a little bit greater. That's why I take 7, not 8, not 9, not 10. Okay. Step 1 is done. I can find k equal to 7. Step 2. If we wish to use 7 classes, the class width I or class interval should be greater than this number. How can I get this number? 4,485.57. This number from the result of the highest, based on our example, the most expensive car price sold minus the cheapest car price sold divided by class 7. Okay, so this calculation, this is the highest, the most expensive car minus the cheapest car divided by number of classes. This is result 4,485, or maybe I can say 4,486 because I round it up. This is I. This is class bit or class interval. This number, no. For convention class size, it is always rounded up. Okay, this is always up. So warning you, this is not class interval. This is the result from our calculation based on our formula step 2. I must greater than this number, this result. That's why I said I 4,490. 4,490. 4,490 is greater than this result. Or you can take 4,500 or 4,495. Okay. So when you try to take the number, try to set the number a little bit bigger than this result. Maybe some of you asking me, our result right from the calculation 4,485 or 86, can we take 85.57? Can we take I equal to 4,486? Yes, correct. You can take I equal to 4,486 because greater than this number. You can take I equal to 4,487 because greater than this number. You can take I 4,488, 89 or 90 or 91, 92, 93, 94, 95. Any number that greater than this number. But in order to save time, in order to make you easy, more convenient, more comfortable, try to take any number that greater than this result calculation. Those number must should, no, I don't say should. Those numbers should have 0 or 5 at the end. Why? Okay, I will tell why when we check our next slide. So you can take, for example, you can take I equal to 4,486. It's not wrong. But if you take 4,485, it's wrong because less than this one. Okay, you can take 4,486, 87, 89, 88, something like, or 90, 91, 92, 93, any number that greater than this number. But in order to make it easy for you, try to take any number greater than this number with 0 or 5 at the end. Okay, 0 or 5 at the end. That's why I take 4,490. Or maybe some of you can take 4,495. Or maybe some of you can take 4,500. It's not wrong. But I just take this one because this one is a little bit greater than that one with 0 adding. 0 ending. This is for beginning or for heading number or ending number, or beginning number or heading number. It depends on word that you use. Okay, so this is I. When you know I, you need to find class limits. Class limit, it should be L1 because we have 7k, k up to 7. That's why class limit must have L from 1 to 7 and H also from 1 to 7. Due to the lowest observed value, the cheapest price car or the car sold last month is 19,320, and the class interval that we just found from step 2, 4,490. So we can determine, we can set us. The first class limit should L1. Okay, the first class limit should L1. This should be the first lower class limit the first lower class limit L1. L1 must be, you can take L1 equal to this one, L1 equal to capital L, but I may prefer you to take L1, the low limit of the first class, a little bit lower than capital L. You can take equal, you can take L1 equal to 19,320, but I prefer you to take a little bit lower. Lower, again, you take, not from calculation, you take or you set, you give the value, you give the number. That's why try to get a number with 0 or 5 at the end. Okay, that's why I take here 19,310, but some of you may take 19,315, or some of you will be taking 19,300. Okay, you can take any number. Maybe a little bit closer, 19,315. Okay, I expect that some of you can take this one and you can do your own way, and then you can compare with my result here. If some of you prefer to take L1, the first class, the first class low limits L1 from you take 19,315. Okay, you may have slightly different from my pictures here. That's why I take L1 lower than this L, 19,310. So if you know L1 and you take L1 plus I, you can get H1. What is H1? H1 high, first class high limit. Okay, first class high limit, because we're talking high limit. High limit of the first class, H1. Low limit of the first class, L1. That's why if you take L1 plus I, L1 plus I, you can get H1. If you know H1, just set H1 equal to L2. What is L2? L2 is low limits of second class. Just take equal. Okay? If H1 equal to this number, L2 must be equal to that number. If you know L2, you plus I, you get H2. Okay, this is H2. If you know H2, just set H2 equal to L3. And you know L3 plus I, you get H3. And doing the same way like this one up to the last one. Last one, it should be 7 because K equal to 7. Last one, it should be 7 because K equal to 7. That's why if you know H6, just take H6 equal to L7. When you know L7, you plus I, you will get H7. Okay, this one. Maybe this slide, some of you asking me about how to set L1. Okay, how to set L1. And the other some of you may be asking me why we need to use the formula. Why we always plus I, plus I, plus I, plus I, plus I, plus I, plus I. L plus I equal to H, L plus Y equal to H. Okay? Because if you know the beginning, L is beginning, and if you want to know ending, the gap between beginning and ending is I. That's why if you know the beginning and you want to know ending, you need to plus I. For example, I can say, this is UC, beginning UC, your house is ending. And you know that UC is this location. If you want, you know how far from UC to your house, you need to know I, the interval, the distance between UC and your house. That's why you will know your house location. So same thing as here. If you know the lower, you plus I equal to higher. But why? Maybe some of you asking me why we need to set H1 equal to L2, H2 L3, H3 L4, and up to the H6 L7. Yes, because this should be continued from step class 1 and class 2, and class 2 must be start from the same point and ending from the same point. Ending and starting. For example, if you're talking about maybe a little bit more more knowledge, if you're talking about accounting, 31st December is the day that we close entry. Tomorrow, just one night, not tomorrow, just one night, overnight, and tomorrow just one night, because at night you don't work. Today, suppose that today 31st December at 5 o'clock, so company closed down. The system or accounting record accounting system closed down. Tomorrow, 1st January, start working. When you set up, when you open, or when you set up, or when you turn on the computer, or when you open the book, so you can see the same thing as you closed last evening. That's why the beginning of the next quarter, ending of the last. Okay, so this is the idea. So after you completing 3 steps, step 1, step 2, step 3, your table must look like this one. Column 1, don't look at column 2, column 1. Column 1, L1, H1. H1 equal to L2 plus I, H2. H2 equal to L3 plus I, H3. H3 equal to L4 plus I, H4. H4 equal to L5 plus I, H5. H5 equal to L6 plus I, H6. H6 equal to L7 plus I, H7. That's why how many class? 1, 2, 3, 4, 5, 6, 7. K equal to 7, step 1. Step 2, what is I? You can see the distance between the distance between this number to that number, the same thing as the distance between this number to that number, and the same thing as the distance between this number to that number, and also the same thing between this number to that number, and also the same thing this number to that number. Okay, you can count it. That's why class interval must be the same for every classes, from lower to higher. I 4,490, 4,490, 4,490, 4,490, and up to the last one. And from lower, okay, this is also I. From lower limit first class to lower limit of second class, also I. That's why this number to that number is I. This number to that number, this is higher limit of the first class. The distance from higher limit of the first class to the higher limit of the second class is also I. That's why you see this is I. This is interval. Okay, so interval. So interval step 2. Step 3, L1, H1, L2, H2, L3, H3, L4, H4, L5, H5, L6, H6, H6, L7, H7. Step 3 done, your table must have this one. Step 4, mark or tally. Transferring, I can say transferring. Okay, maybe I'm not going back to the data set. I just take a small number from the data set. This is the price of the car sold, the first car sold last month, second car or second car. It depends on what way that you, what direction that you count to from up to bottom or from the left to the right. The first car, second car, I count first car, second car, third car, fourth car, and up to the on. Okay. Now step 4, tally. Mark. How to tally? Okay, look at the first car. The first car sold last month with the price 30,373. 31,000, not 30,000. 31,000. This number should go to which class? Which class that has this number? 31,000. I will go. 19,000. No. 19,000 to 26,000. No. This number not go to the first. 23, 28. This number also not go to the second one. 28,000 to 32. 28,000 to 32,000. That's why 31 must inside this class. So I will put mark 1 here and I cross here. Why I cross here? It means second time I'm not looking this number again because the number already cross. Already cross, it means that I already tally here. I already make mark here. Okay. Next, 39,000. Which class that 39,000 should be going to? 32 to 37? No. 37 to 41. Yes. 37, 41, 39 must be inside here. Okay, then I put mark here or tally here, I cross again. Why I cross again? Next time I'm not looking both of them. I will looking the one who not cross. This easy for me to save time and not confusing, not doing it wrong. The other one, let's say the third one, 32,000. What class that 32,000 going to? This is 32,000. This is also 32,000. 32,700. 32,700. So this one or that one? 32,778. 32,780. 78 smaller than 80. That's why 32,778 must go to class 3. Okay, so do the same way for all 80 prices. That's why finally when you complete step 4 must be like this one. After completing step 4 table must be this one. Okay, and then when you count this number, this is 5, 5, 5, 5, 5, 5. This is 1. That's why I can say 5 2 times 10, 5 4 times 20, 5 4 times 20, 5 3 times 30, 5 1 times plus 3, 8. No, it's not 5, only 4. This is 2. That's why I just transfer step 5. Just count this mark or transfer this mark into number. Step 5 done. When step 5 done, this is the table for frequency distribution. Okay, so step 4 we call tally, step 5 we call frequency. This number represents class frequency. What does it mean? The first class there are 10 observations. Second class there are 21 observations. That's why I can say that the first class frequency is 10, second class frequency 21, the third class frequency 20, and the fourth class is something on up to the total. Total must be 80. Cannot be 39, cannot be 79, cannot be 60, cannot be 90, cannot be 85, cannot be 100. But it's only 80. Why? Because last month there were 80 cars sold. Okay, so step 1, step 2, step 3, step 4, step 5 done. Now when you have this, how can you explain? How can you say something? How can you interpret? How can you present this table? This table called frequency distribution. How can you interpret frequency distribution table that you have done here? In order to interpret, in order to summarize, in order to explain, or in order to present, you need to rest. You need to make only main point. Okay, so in this case, based on this one, there are 3 main points. First, you need to show about coverage or range. Range, what does it mean? Coverage or range is a scope, a size from everything that we study, that this class show you. Okay, not the class. Everything that this table show you. This table show us about selling price in thousand. Okay. So based on the previous table, the price of car sold last month ranged between 19,315 to 50,740. Range from L1 to H7. L1 to H7. So based on this table, we can say that no car sold with the lowest price than this one or with the higher price than this one. No car sold last month with the lower price than this one or higher price than this one. So all cars must sold last month within these prices from 19,000 to 50,700 something. Okay, this is range. Second one, the prices are concentrated between. What does mean concentrated? Closer, more happen, more frequency. Concentrated, the closer or more happen or more frequency. The prices are concentrated between 19,310 to 37,270. Okay, based on this one. This one. Okay, you can see when you look at frequency, this class have more frequency, 2 digits, while this one is only 1 digit. That's why most of the car sold in this price. Most of the cars sold this price. Okay. Second one, the price of 66 car or maybe 82.5 car with this range. 82.5 the most, because over than 50 is the most. That's why 66 over 80 car sold is the most car sold. The largest concentration or the highest frequency is in 23,800 to 28,290 classes. There are 21 cars sold in this price, within this price. The middle of this class is 26,045. So we can say that typical selling price of a car is 26,045. Okay. So look at this one, 23,800, 28,290. This one the highest with highest. This one, this is also higher, but not really highest. This is the highest one because one extra. Okay. So, how to summarize, how to interpret, how to explain? Yes, you can use 3 points here. You may ask me, do we need to use all these 3 points every time? No. It depends on your table. It depends on your table. Some table maybe you do only 2 points. You do only 2 points. This one will be used. This one sometimes used, sometimes not used. Or this one sometimes used, sometimes not used. That's why this one must be used. This one sometimes used. If this one used, it depends on you. But it's much better to use these 3 points. Okay, this is called the highest 21, the highest classes. This is a concentration, and this is a range. Okay. Okay, next study for other example on a textbook, page 30 to 33. Sales review 2.2 on page 33. Okay, you can do it. If you have some something not clear or question, yes, you can contact me. The other one, this is easy one, not many numbers. Other example, raw data below is an age sample of 30 students. Suppose that in your class not only 30 students, not only 30 students. Okay, there are more than 30 students, but I take only 30 to study. That's why I call sample. This is should not M. This is should be in small m, not a capital M. Okay. Who taking in introduction to statistics? So 30 students that take from your class. This is sample, not population. This is the first student. When I ask, how are you? The first answer, 22, 20, 24, 21, 21, 20 something like here up to the last one. So I got a data set here. I want to make this 30 student age into frequency distribution table. So because 30 student asking, that's why n is 30. This is small n, not capital N. Okay, that's why you need to find minimum. It should be the youngest student. Youngest student 820. You can see all number 2, heading number, all number 2. That's why you need to look at maybe second. This is 1, this is 0, 0, 0, 0. Okay, 0. This is 0. The oldest student is only, yes, because all heading number, all number 2. That's why look at that the ending number 4. It's only 1 4. Okay, that's why you can set k. So k equal to 5. How about I? In order to set I, you need to calculate this result. The oldest minus the youngest divided by class. Okay, that's why this is less than 1, 0 point something. So 0 point something, you need to take 1. You may ask, why not take 5 or 0? You cannot take 0 here because this is only 1 digit. I mentioned earlier, you need to take I, you need to take class interval, lower limit, higher limit of each class with any number with 0 or 5 at the end. Those numbers with many digits, many numbers, but this is only 1 digit, only 1 number. You cannot take 0. That's why you can take any number if only 1 number or only 1 digit like this one. That's why I take 1. So lower, higher, lower, higher, lower, higher, lower, higher. Because class interval is only 1. It's not good look to do this one. That's why I go that one. I do this one. Okay, I do this one. From then I take this one. Then tally at step 4. This is step 3 already done. Step 4 tally. Step 5 count the tally. So when you count the tally, you can get a step 5 frequency. That's why every group have their own frequency. When you add all them together, must equal to n. Okay, must equal to n. Cannot be bigger than n. Cannot be smaller than n. If bigger than n or smaller than n, the way you tally is not correct. Check your tally again. That's why when you count all, when you sum all, when you add all together, and the result not equal to 30, you will feel I do it wrong. How can I check where do I make it wrong? That's why you need to check tally. In order to check tally, as I mentioned in the previous one, yes, don't forget to cross, okay, to cross original data when you count into our tally. That's why you look at back again. Which number that not yet cross, okay, or which number that cross 2 times. Cross 2 times means you take 2 times, because this represent cross 1 time. Take king, take king, take king. If you're not crossing, not yet taking. But if you cross 2 times, you take 2 times. That's why this must be greater than n. If you found something not cross, some number not cross, that means totally here lower than n. Okay, lower than 80. Or if you cross 2 times for some number, must be more than 80. Okay, so I finish this movie. For the third movie, I will finish by now. Okay, and again for you to work on YouTube, don't forget to subscribe. The one who not yet, the one who already done, okay, not for you. I said only the one who not yet subscribe. Subscribe, comment and like for everyone. Okay, because in one channel you can subscribe only 1 time. That's why the one who already subscribed, you don't need to do it. Just comment and like. But the one who not yet, because I observed that some of you, of few of you, not yet. did it. Okay, did it. Yes, maybe I go to that one before. Class mark, class midpoint. You know midpoint? If you know lower, yes, based on our concept, we have L, we have H, lower and higher. Lower it means beginning, higher means ending. If you want to know midpoint in between is exactly the middle between lower and higher. So class mark or class midpoint is a point that divides a class into two parts equally. This is a range between upper limit and lower limit of every class. So how to find class mark or class midpoint? That's easy. H plus not minus. Don't confuse. Okay, don't confuse. H plus L divided by 2. H plus L divided by 2. Class interval. For class interval, step 2, remember step 2 from our process in order to make frequency distribution table. Step 2 at that time. But now, suppose that you already have a table, frequency distribution table, or one frequency distribution table is given to you. That's why you don't need to run 5 steps, because table is already done or table is already given to you. So how to find class mark? Based on this one, you need to get H of any classes plus L from that classes. You take, for example, if you take any classes. If you want to take class mark, you can take H from any classes. For example, class 1. If you take H1 must plus L1, not L2. Okay, because class midpoint 1, H1 plus L1 divided by 2. Class midpoint 2, H2 plus L2 divided by 2. So if you take midpoint what class, you need to take limits of that class to calculate. Okay, if you take midpoint or class midpoint or class mark from what class, you need to take the upper limit of that class. You need to take lower limit of that class. Don't take from the other class, otherwise your class mark will be wrong or your class midpoint will be wrong. Suppose that again table is given to you or table is already done for you. You have table right now. How to find class interval? For a frequency distribution having classes of the same size, every class has the same size. Every class has the same size here for class interval. The class interval is obtained by subtracting or minus the low limit of the class from the low limit of the next class. Low limit of that class from low limit of the next class. Okay, class interval, for example, L7 minus L7 minus 1. L7 minus 1 is L6. Okay, or you can find in this case you can find 5 ways. You can find for example, in this case L7 minus L6 class interval, H5, if you can H5, H not L, H5 minus H4 class interval. Okay, class interval. You can take class interval. If you have that table, you can take maybe mini formula in order to get class interval. Based on this one, let's say LT8 minus LT8 minus 1. Let's say T8 is 5. If L5 minus L4. If L3 minus L2. If L7 minus L6. Or you can, if you don't want to take L, you can take H. If you can take H, H5 minus H4. H7 minus H6. Okay, or you can take H1 minus H1 minus L1. You can find classes. Or if you want to get midpoint, you can get midpoint class midpoint 7 minus class midpoint 6, class midpoint 3 minus class midpoint 2. You get interval. That's why in order to get interval, when you have a table, you can use 4 ways. You can use 4 formulas. If you want to use L, like this one, if you want to use H, just the H minus 8 this class minus 8 lower class or next class. Okay, or you want to use class midpoint this class minus one next class. Or if you want to use H and L at the same class, H minus L in the same class. This is the class midpoint. Okay, now go to you cell review 2.3 on page 34. Okay, 34. Maybe I just going to their wait. Yes, I just stop right now. Okay, now we already look at class midpoint, class interval. But remember this one, I remind you, this one is only when you have table of frequency distribution. If you don't have table, or table is not given to you, you cannot use this one. You cannot use this one to find class mark or class interval. You cannot use this formula to find class interval. Okay? If it gives raw data set to you, you cannot use this one. You need to use 5 steps first in order to use this one. But if table given to you is table already done for you, you can use this one based on the table. Relative frequency distribution. If you know, if you have frequency distribution, if you want to find relative, maybe we already did in the first movie. Okay, maybe I'm not reading this one for you. I just go to the formula. Relative frequency of class 1. Let's say class 1, because every class has its own frequency. If every class has its own frequency, those classes also have its relative frequency. Okay. In order to find relative frequency of the class 1, you need to take class frequency from class 1, class frequency from class 1 divided by total frequency. Okay. So to convert a frequency distribution into relative frequency distribution, you need to use the formula. Relative frequency distribution is the method of converting frequency distribution into percentage or proportion. It shows fraction of total number percentage of items in each class. Okay, based on our example, when you look at our table that we already done 5 steps, the first class has 10 frequency. Frequency of the first class is 10, frequency of second class is 21. So, how to find relative frequency of first class? In order to find relative frequency of first class, take the first class frequency divided by total frequency. Okay, that's why you got this one. This is called relative frequency. Relative frequency for the second class, take the second class frequency divided by total. This is proportion. Okay, proportion, not percentage. How to get percentage? Just multiply by 100. That's why this could be decimal number or percentage number. This is decimal number. When you add all them together, must equal to 1. 1 is 100%. Okay. So now cell review. The other cell review. The other cell review is 4.4 and homework. homework on page 35, 36. Okay, 35, 36. So now is ending to this movie. So go back to you, and don't forget, the one who not yet subscribed, subscribe, comment and click like. Comment and click like for everyone. Subscribe is only the one who not yet doing it. Okay.